concept of near-field antenna. Radio frequency identification, RFID, technologies, which were developed during the World War II, provide wireless identification and tracking capability. The reader antenna is an important unit of RFID systems. Many new RFID antennas are developed for different applications. Reader antennas can be classified into two types based on the working scope for different application purposes: near-field antenna and far-field antenna. Currently, ultra-high frequency, UHF, near-field RFID technology are fast developed in item-level identifications such as sensitive products tracking, biological products and medical products, blood, medicines, vaccines, biosensing applications and so on. The basic consideration of UHF near-field RFID is to make it work in a short distance stable, just like what LF/HF near-field RFID does. Inductive coupling systems are selected in most applications in near-field UHF RFID, because most of the reactive energy is stored in magnetic field. Inductive coupling is more stable than the capacitive coupling and hardly affected by liquid or metal. In a near-field RFID system, the reader and the tag antennas are coupled mainly through magnetic field. If the tag antenna is electrically small, the magnetic field of reader antenna is perturbed by tag rarely, and coupling coefficient C could be shown by the equation. Where Φ an operating frequency, N tag is the number of turns of the tag coil, Cis the cross-section area of the coil, this the magnetic field density at the tag location, and alpha is the antenna misalignment loss. One of the challenges in UHF near-field RFID applications is to design a reader antenna with wide bandwidth and strong near magnetic field simultaneously. Strong near magnetic field is important for extending the reading range. Low gain could reduce interferences. Wide bandwidth antenna could be applied at 840 to 960 MHz, which covers both ETC of Europe and FCC of North America. In some special application scenarios, smaller size antennas are required because of the limited system space. Some near-field antennas have been reported to generate strong and even magnetic field. Mini traveling wave antenna is proposed to extend the bandwidth. A conventional traveling wave antenna called mini guardrail from a famous company Impinj has wide bandwidth of more than 200 MHz at UHF band as well as low gain. But because loads of traveling wave antenna consume too much power, current and near magnetic field are not strong enough. The magnetic field should be lower than -13 dB/m at any direction if the distance above antenna is larger than 2 cm. Conventional standing wave antenna could present a strong magnetic field, but its gain is too high and bandwidth is too narrow to cover a wide UHF RFID bandwidth. Typical standing wave antenna with strong magnetic field like I-shape is proposed by Lee et al., but -10 dB bandwidth is only 30 MHz, which could only cover FCC band. Narrow bandwidth antenna is easily detuned by environmental changes.